Section 2.4, Significant Figures in Calculations. Here is where everyone hates my guts. When you are doing math with measured numbers, you have to have embedded in that answer, you have to know how iffy your measurements were. So I'm going to give you a scenario. If I were to measure with a yardstick one side of my room that had no marks on the yardstick, just a piece of wood that's exactly 1 meter, I'm making a big guess at the end of that measurement. I'll say it's 7 meters plus some of the other, okay, and I can make a guess. If I measure the other side of my room and I'm measuring with a yardstick that goes all the way down to milliliters or millimeters, and my last estimate of guessiness is in between 2 tiny little marks very close together, then I will have a number. I could say 7.4 for the first one and 3.62 for the second one. I can put those 2 numbers in a calculator and get an answer. But by doing that, I have 2 pieces of measurements that are different. I have one really big guess and one really small guess embedded in a math problem. For that reason, I'm indicating that the room is specifically measured when really there's a lot of guess there. So when I'm doing math with numbers, I have to relate how much guess was in those measurements. And otherwise, as long as I contain that amount of guess in it, then I can convey that properly. But I can't simply just do anything I want. That means that there's rules for calculation in significant digits, and that's what we're going to do today. All right? The answers have to have the same number of significant figures as the measured numbers. So I can't put the 2 numbers in my calculator and then my calculator has decimals down to the 7th place or something like that. It makes it look like it's very, very precise when really it was just lots of guessing. So I can't do that. I have to have the same number of significant figures in my answer as I did in my measurement, right? So we round to digits. You're going to round up. So remember in grade school when you did rounding, if you had 4.5 and you wanted to round to the nearest 1, 0.5 allowed you to go all the way up to 5. Okay, so 4.5 would be recorded as 5. Because I rounded that 0.5 up. Okay, so rounding rules are going to be used to obtain the correct number of significant figures when you do arithmetic with these answers. All right, so this is a rounding rule. If you have 0.4, then you round it down. Okay, so if you have 4.4, you would write the number 4 down. If you have 6.4, you'd write the number 6 down. If you have 10.4, you'd write the number 10 down. If you have 0.5, that's enough to round up to the next number. So 4.5, you'd record 5. 6.5, you'd record 7. Right? So to round off 45.832 to 3 significant digits, well, what are your 3 significant digits? The 4, the 5, and the 8 would be the 3 significant digits. That means you're gonna look at the 8 and you're gonna look at the 3 and know, is it a 5 or more? If it's 5 or more, then the 8 would go to a 9. If it's 4 or less than 5, it stays at the 8. So if you're gonna round 45.832 to 3 significant digits, your answer would be recorded as 45.8. Right? So that's the first idea, the idea of rounding. So if it's 5 or greater, you round up. If it's less than 5, you stay the same. Okay, you keep it at that same number. Let's do one more. To round 2.4884 to 2 significant means that the 2 is significant and the 4 is significant. Now I'll look at the next digit. It's more than 5. That means that I have to round up. So the 2.4 rounds up to 2.5. Okay, so that's how you would explain it. So you're rounding to the same number of digits. your answer has to be the same number of digits as the numbers you're going to use in your math. That means the numbers you use in your math have to be the same as each other in order to add them or subtract them, etc. And we'll look at that in a second. Okay, so let's look at adding. Sometimes a calculated number requires more significant digits. Then one or more zeros are added. All right? Okay, so if your calculator answer is simply the number 4, but your measurements had 3 significant digits in them, then I express a 4 as 4.00 because that's 3 significant digits. Okay? If you have 1.5 and there's 3 significant digits in your measurements, that means your answer has to have 3 significant digits, then you have to say 1.50. Okay, except, so 12 would go to 12.0 if there's 3. 0.2 would go to 0.200, that's 3. Okay, if you remember, the 0 in front of the 2 is not significant. Okay, adjust the following calculated answers to give 3 significant figures. All right, so the first 3 would be significant, 8, 2, and 4. Look over to the next number. It's a 7, which is more than 5. That means the 4 goes up to 5. So your expressed answer would be 825 centimeters. Okay, what about the next one? I want 3 significant digits. So the 0 is not significant since it's leading. The 1 and the 1 and the 2 are. Now look at the next one. That's a 4, so leave it at 2. So your expressed answer would be 0.112. Last one, 8.2. I want it to be expressed as 3. Well, your calculated answer is 8.2. I need to add a 0 after the 2 to express 3 significant digits. If my measurements were 3, my answer has to be 3. Okay. All right, here's where we're calculating with these measured numbers. And this is where the headaches start. Let's do the easy ones first. Multiplication and division. When you're multiplying and dividing, use the same number of significant figures in the answer as the fewest significant figures in your numbers that you multiplied. Right? So you look at the number of significant figures in the two numbers that you're multiplying together, and whatever the fewest is, your answer has to be rounded to that number. All right, so let's look at an example. 110.5, that's 4 significant digits, multiplied by 0048, that's 2 significant digits because the first 2 zeros are insignificant. That means whatever your calculator says, you ignore it and round that calculator answer to 2 significant digits because I'm rounding to the smaller number of what I measured. So if my smaller number was measured at 2 significant digits, my answer has to be 2. So I put it in the calculator, get 5.304, and then round to 2 significance, which means I go to the 3, look over, it's a 0, it's not a 5, so it stays 3, 5.3. Okay, let's do some of the easy ones. This works with multiplication and division. All right, multiplication and division. All right, so the first one has 3 and 2. So I'm going to round to 2. All right, so when I look here, my calculator gives me something. Which one has 2 significant digits? Number 2 does. So A is 2. Okay. In B, I have 4 and 1. Okay, I hope that you're getting good at this, being able to know how many significant digits it is. I have 4 and 1. That means I need to round to 1. Which one has 1 significant digit? The 60 does. Okay. Notice that it's 60. It's not 6. It's 60, but I want 1 significant digit. So that 0 with no decimal place, so 0 with no decimal after it, is indicating that it's in the ones place, but there's only 1 significant digit. The 6 is significant. The 0 is trailing, and so it's not significant. So number 3 for B. All right, here's a division problem. I've got 2 numbers on top and 2 numbers on the bottom. All right, so I've got 3 and 2 on the top. I've got 3 and 2 on the bottom, so I round to 2. Whatever the smallest number in all of those numbers are, the smallest number of significant digits, that's what I round to. So the one rounded to 2 is number 2. All right. Adding and subtracting is a little harder because it's not numbers of significant, it's where that significant is. It's the place value of the significance. All right. In fact, it's the least significant. So when adding or subtracting, the same number of decimal places as the one with the fewest decimal places. All right, so let's look at this. 25.2 has 3 significant digits, but it goes to the tens place. So it has 1 decimal place. Okay, it's to the tens place. 1.34 has 3 significant digits, but it is significant to the hundredths place. So if I'm doing math computation with these two numbers, I can't go to the hundredths place because one of my digits are only significant to the tens place. That means your answer has to be to the tens. When you're multiplying and dividing, it's easy. It's just number of significant digits. When you're adding and subtracting, it's to the, I think of it as to the one to the most left. Look at your two numbers you're adding and subtracting. Which one goes most to the left? Round to that place. So in this case, the 2 is the one farthest to the left. I round to the tenths place. So my calculator answer is 26.54. So I round to the tenths place. So the 4 doesn't make it go up. It just keeps it the same. So 26.5, 1 decimal place. So let's look at it. I have 235.05. That's to the hundredths place. I'm adding 19.6. That's to the tens place. I'm adding a 2. That's to the ones place. That means my answer has to be rounded to the ones. I can't have any decimals at all because they would round off. So the number A is 1, 257. What about the second one? I have 5 significant figures, but it's significant to the thousandths place. That 5 is in the thousandths place. The 2 in the 18.2 is to the tens. That means my answer has to be to the tens place. So which one is to the tens? 3. So B would be 40.7, would be to the tens place. Okay, we'll do some examples with this in class, but hopefully this will give you some idea so that you can come slightly prepared.